Hello. Today I will show the solutions to Prairie Math League High School round number 122, problems 5 and 6. So to start, we have a parabola with a vertex in the fourth quadrant, 5, negative 7, here. And we have two x-intercepts, one positive and one negative. If this parabola is the graph of y equals ax squared plus bx plus c, which of a, b, and c must be positive? Now here we have a parabola that satisfies. So we can use this to counter-prove a few things, but to start off, we're going to start with A. A is always positive, of course, or else our parabola would actually kind of look like this. And then we would ask to ourselves, where does this parabola ever intersect the x-axis? The answer is it doesn't. So this thing is something we're not going to consider, and A will have to be positive. Now, the sum of the roots, in this case, is obviously positive, because probably about somewhere here. Hence, by Vietta's formulas, which basically states that b divided by a, the negative of b divided by a is the sum of the roots. So by Vietta, we have this here. Negative b over a is greater than 0. Hence, b is less than 0 in this case, which is already a clear counterexample to our assumption that b is positive always. So finally, we can go on and see that in this case, the x-intercept is negative. So if we plug in 0 to the original equation, 0 here, here, then we see that the y-intercept is negative, so c is negative. Hence, we only see that a is always positive, so the answer is A. For problem number 6, we have a triangle as a binary operation. Now, what is a binary operation? A binary operation, as we can infer from the context, and it is the definition, is that basically it's an operation that takes two numbers on the side and returns like another number. So this can be something like addition or multiplication. But here we have triangle, so this is the new one that we're defining. And let this be a binary operation on the natural numbers, satisfying the properties so that for all a, b, and c, a plus b triangle c is equal to open parentheses a triangle c close parentheses plus open parentheses a triangle c close parentheses. And yeah, a triangle open parentheses b plus c close parentheses equals open parentheses a triangle b close parentheses triangle c. So yeah, this basically means that we have two properties, number 1 and number 2. So now we're given a value of a and b that returns we're given two input values and we get an output value. So 5 triangle 5 is equal to 160. And now we want to find 7 triangle 7. So how do we start this problem? Well, we can take a look at the property number 1. We have that we have this. So a plus b triangle c. And this sort of resembles distributive law, but except that it's a triangle instead of multiplication. So what can we do here? Well, we can try plugging it in for some values. For instance, we can try 4 and 1 for values of a and b, and 5 for c. So here we have 4 plus 1 triangle c. This is 4 plus 1 triangle 5. This is just 5 triangle 5, which we know to be 160. Now here we can see that this is 4 triangle 5 plus 1 triangle 5. And yeah, this is 160. But we don't really need to consider that for now. So now what do we notice here? Now we can actually apply the same steps on this thing. So this becomes 4 triangle 5 we can make is equal to 3 triangle 5 plus 1 triangle 5, and so on. So then finally we have 5 triangle 5 equals 1 triangle 5 plus 1 triangle 5. We just basically repeated the same thing over and over again. And one more. So now we can also apply this in the general context. Here we have A triangle B. And with a similar process, we can just break A down into A minus 1 and 1 and apply property 1 to get A identical terms, which we can combine to get this here. Now notice that we've only used property 1. So now we're going to start looking at property 2. But this time we're going to focus on something that we haven't solved yet, namely 1 triangle B. So to simplify things later on, let's call U be 1 triangle 1. So basically this is like our unit here. Then 1 triangle B, we can just plug in A equals 1, B equals 1, and C equals B minus 1. Yeah, variable names probably are confusing here, but you just hang on in there. So, yeah, this applies by property 2. And notice here that we have our unit that we defined earlier. So, here, U triangle 1 triangle B minus 1. So this might look a little confusing, but the key point here to take away is that at the start we had B here, 1 triangle B. And by the end we actually had U times 1 triangle B minus 1. So what has this done? So basically we removed 1 from the right hand side. From the right of the triangle. And we also multiply the entire expression by U. So by property 2, we basically have these steps. And we can repeat these steps. 1 triangle B, and we can note that this goes on. We can just keep on and multiplying by U and taking away from the right-hand side of the triangle. And eventually get this. Now, this isn't exactly a rigorous proof, but it's really easy to use induction to prove this, just by using the base case 1 triangle 1 and then going up to your desired 1 triangle B. Hence, we can now use these two properties, this property, and we have this. So nice, we have a general formula for triangle. Now all we need to do is solve for U here. By applying 5 triangle 5, we see that 5U to the power of 5 is equal to 160. So U to the power of 5 is 32. So U is equal to the 5th root of 32, which is just 2. Therefore, we can just plug this back in. 7 triangle 7 is 7 times 2 to the power of 7 is 896. So our final answer is B. Thank you for watching.